Ladies and gentlemen, I'm going to make a presentation today about the TILOS software. It stands for Time Location Software or Schedule, and it's a planning technique for obviously for projects which have got time and a distance, so roads, railways, pipelines, etc. And so I want to talk a little bit about time location planning in general, but TILOS is not just to paint a picture, it's also got some advanced project planning capabilities, resource management, cost management, and progress control. So TILOS opens up this sector to you. My name is Richard Ormerod. I've got a background in the construction industry and have been working with TILOS for quite a long time. And I show this slide at the beginning often because every picture tells a story, and that is what a time distance diagram does. It allows you to convey the whole scheme on one piece of paper. Okay, it might be a big piece of paper, but everybody can understand what's going on. You don't have a book of A3 bar charts or a massive network diagram that nobody can understand. You've got a picture, and this is the earliest example that I could find. This is distance horizontally, and this is Napoleon's invasion of Russia to Moscow and his retreat. So the size of the rivers, the Brown River is the size of his army heading out, and the Black River is the size of his army heading back. So you can see a huge amount of information once you understand that basic premise. And that's the same thing with a time distance diagram. So traditionally, you might be using various tools. So it might be P6, Power Project, Microsoft Project, others, where you've got two activities that you link together with logic links, and you view those in a network diagram without a timescale, but nobody really uses that because everybody is going to convey that to somebody else by displaying it against a timescale. So then you get the bar chart, the Gantt chart, and so that conveys more information. You can see that task B follows task A, both in start and in finish. But if you're working on a linear project, you've got an extra dimension to play with. You've got time and distance, location, and it doesn't matter to TILOS which way around these diagrams are. You can have location vertically and time horizontally, and if this is traditionally the sort of what happens in the UK, where we've got distance horizontally, in continental Europe's often the other way around. But then it doesn't matter which way the axes go. You can have the location going left to right. You can go Birmingham to London, or you can go London to Birmingham, and you can have the timescale so that early tasks start at the bottom of the page and work up, or they start at the top of the page and cascade down. So that is the most common situation that I find. And then if we put the same activities that we had in our bar chart, very simple plan. So we've got task A, and we can draw that on the diagram with its start and end distance and its start and end time. And the unique thing that gives about is if I said, when will you be at the end of 1 kilometer, then you can read that off the diagram. You can understand at what date you'll reach that point. And if you've got that on a bar chart, you do not know that. So that's crucial information of this whole technique. And also, you can see there's a bit of change of direction in that plan. So you can also visually see the rate of production. You can see one task relative to another, and later on I'll show you can have within a single task, you can have changes of productivity, and that can be displayed on the diagram, and it's giving you information. So if we put task B overlaid on that, it starts and ends after task A, but because of that change of production, you've got this problem. Two activities are taking place at the same time in the same space. So two crews have bumped into each other, two machines have crashed into each other, two trains have potentially, so it's probably not that dramatic, but there are things that you need to find that situation. You need to avoid that situation often, or you can allow it, but primarily you're trying to avoid that situation. And TILOS has unique features to allow that to happen in a way that you couldn't do it in any traditional planning software. And then you've got physical obstructions, so things like there's bird nesting season at a particular location, or there's a this field is not going to be released to the road route for legal reasons until sometime later on, and you have to find a way around that problem. And again, there are elegant solutions to that in Tylos that are more difficult to find in a traditional software. So that's the benefits and the techniques, and why time, distance, time, location, time chainage, they're all the same terminology, why that's useful. But I want to turn to Tylos now and just convey two key pieces of information. And one's about views. And so a view in Tylos is the thing that you're going to work on, and you can make new ones. And it's a graphical representation. It's made up of cells, a bit like Excel, and you can stretch each cell and say how big it is and what it contains, what sort of data. So I'll start off with a time and distance cell at the beginning, and those different shapes and colors and lines, they are the activities themselves, and we're going to return to that topic in a moment. But when you make that first cell of a view, you choose what the orientation is. Is time vertical or is it horizontal? And in my plan, it's vertical, so that blue stripe is a holiday period, and then I can create a second cell on top of the first one, and that's a distance cell. And in there, I can create my own distance ruler with as many rows as I want, different information in there. I can have another distance cell, and in there, I can include a map of the route, but I'll show you, I'll be doing that shortly. You can have a time cell on the time axis, and here you can build your own highly flexible time ruler where you don't have any restriction on the number of rows or columns that you might have. If you've got resources on the plan or cost, you can see individual quantities of those. So Tylos doesn't do resource leveling, but it does very good resource planning. And you can have a period graph, so we can see how much money, man hours, cubic meters of spoil are in a time period, week, month, hour, minute, etc. So that either in a period and also cumulatively. We can graph unique points along the distance axis, so things like stations on a railway, overhead line, mast positions, bridges over a motorway, that sort of thing. People want to pick those out, and you can also graph resources and costs on the distance axis, and you can have a distance Gantt chart as well, which is quite an intriguing and useful thing. But also there's a special module within Tylos where you can have what's called a mass haul diagram, and I will also be talking about that a little bit later on. So that's a view, and that's what you work on screen, and you can print it off, and it's exactly what you get. And you can have multiple views, so you can have a distance slice. So I can say, well, so I've got graphics in this view as well. I've got a legend of what these different colors and patterns mean, which we'll talk about in a moment. And we can have graphic files embedded to demonstrate logos or other illustrations and a title block. But we can also say, well, that's fine, but I'm going to have another view that's only showing me what's happening in October and November, and only between 1.5 and 2.5 kilometers. So we can zoom in on that footprint, as well as having a traditional filter based on other criteria. So views are important to understand. I'll be using views, but you can obviously create them in Tylos, and views are like views in Power Project or Microsoft Project or layouts in P6. But unique to Tylos is the idea of a task template. So different tasks have a different appearance. How do we nominate that appearance? So tasks are just as they are in all those traditional systems. They've got a start and end date, logic, links, resources, calendars, all of those things, and a number of tasks that go to make up a project, which can be all seen in a view. But when we create a task in Tylos, before we create it. We nominate a task template, and a task template is a library of shapes and colors and line styles and fill patterns. So we're saying that all topsoil strips is going to be a brown line, or all culverts are going to be a yellow box. So we make a library with topsoil strip in it and culvert in it. So when we create a task, we just say it's one of these things and it has already got that appearance. So having that pre-prepared library is the starting point. And not only can it have a shape and a color, it can have a rate of production. So we can strip topsoil at 120 meters an hour or some productivity rate, and it can be preloaded with resources and costs. So we're going to have this particular machine, 2 men, 15 litres of diesel an hour, and it's going to cost X. So all of that can be pre-prepared. So it's more like a library of prototype tasks that don't yet exist, which we're going to use. So now I'm going to turn to the software itself. So I've already got Tylos open on screen, so it's quite a sparse interface. And what we're going to do is we're going to create a new project from scratch. Okay, so and I'm going to base it on a template. So this is like Excel or Microsoft Project or Word. So it's a file that I can email around. It's not a big database that we don't have access to. So I'm going to nominate a starting point, and this has already got task templates, views, calendars already created in it, for example. And this is these things are installed when you get the software, and you can obviously adapt them. And now we need to say a few things about the product, this particular project. So I'm going to say that this is the A14 dual carriageway, and we have a unit of measure. So should we be thinking about meters or kilometers or even miles and yards, and I'm going to do it in meters. So I've got a 15-kilometer road that we're going to be working on, and we're going to do this from it's coming up, so we're tendering on this. It's on the 4th of January next year, and time has got more of a importance in Tylos, so we need to put a time as well as a date in, and we anticipate this project going on till later that year. So we need to put in the footprint of what's it called, when does it start and finish in distance, when does it start and finish in time, and a couple of other things here. So when we click on apply, it's going to take a copy of the template, save it on this any file that this can reach. Okay, so it doesn't like my U drive, so I'm going to have to just change the destination where we put that. So then we've got the user interface that I want to take a moment to just talk about so that you're vaguely familiar with what's happening. So on the left-hand side of the screen, we've got this section we call the Explorer. So this shows us as a tree structure, all of the views that we talked about, project data and data in the main library itself, all of which can be created in advance. And then on the right-hand side of the screen, you've got this large area that we're trying to make as large and uncluttered as possible. And this is our time distance diagram. Down below are a series of tabs, and these change depending on what we click on. And all of these things are obviously interrelated. So, so let's just get rid of those, because also there's quite a lot of buttons. So there's a whole series of buttons up here about housekeeping, save, undo, redo, and then there's a bunch of stuff here about changing the zoom scale on screen. All of these are going to be used to do something on the body of the diagram, and you get tool tips as you hover over any button. So that's a quick tour. So we expand and collapse these things in the Explorer, as you would expect. I'm going to open a view that's already created, and I'm going to double click on that. So this window is now about this layout, this view. And what I want to do, first of all, just to show you how these things work, is I'm going to put a diagram in this particular box here. So what I'm going to do is go onto this toolbar button, click on it, and I'm going to set a couple of parameters which I can change later. So I want it to scale horizontally, and the top left-hand corner is going to be where we anchor this box in relation to the cell. And I'm going to open the I'm going to open a picture to include in there. So any graphics file, and we can do other sorts of files. And so you can see there now I've got a picture inside that cell, and I can scale it and change it. So the blue two-headed arrow, change it, four-headed arrow, just move it around. And we've also got these vertical and horizontal sticks that you can adjust, and you can set that against this distance scale, because we know that this starts at 1500 meters and goes to 15,000. So we can locate it exactly because we can scale it by distance. So it's full of things like that. We can put logos in on the right hand side, and we can do a bit of Excel. So as a title block, so I'll perhaps do that. So if I want to scale this in both directions and connect it to the bottom right of the diagram, I'm just going to draw a box in that area, and in there I'm going to not bring in a picture, I'm going to bring in a bit of a Windows object. So this is object linking and embedding. So I'm going to open a file that is a starting point with the printer area set. And so when I say, okay, it's starting Excel in the background, and then it's allowing me to display its contents. I can edit Excel by double clicking on one of the blue editing handles, and I can say in Excel, I can't connect to the data in the project, can't embed data, but there are other ways of doing that. So when I save it, you can see that being changed on screen. So this layout, so it's like half using a CAD system and half using a project planning tool. But let's turn to the project planning aspect of it. So we're going to look at the library where we've pre-created some task templates, and I've got mine in sort of a hierarchical arrangement, which is possible. And the very first thing we're going to do is do some topsoil stripping. Now, even if I can't see all of that, when I create a new task manually, I click on this button, insert a new task, and I've still got access to the library that I want to get to. So I've nominated a task template, which is defining the shape and the color and other things potentially. And I'm saying, well, from this point on the screen to this point over here. And as I do so, you can see along the top of the screen that the distance and time, the duration and the length is being set. And of course I can edit this manually. So I'm doing it on this toolbar, but I'm also with this object selected. It's got the blue editing handles. I can still move it around in the same way that we did before, but I can change the name here and change the dates and everything. So just as you really would expect. So it's going to take me 25 days, but unlike a Gantt chart, you do not have a spreadsheet area, a column area on the left-hand side or the right-hand side to display information. So in Tylos, you do that by adding a text annotation. So this is possibly the trickiest thing to get to grips with, because there's no ideal layout. So we can type information in this box. So we could starts on, and rather than putting a date in there or a distance, I can press the F8 function key that this little bit of help talks about here and pick from a list. I want to say it starts on a certain date. So I can pick a date, a start date for about the schedule in various formats. And I'm going to say also that we can put the @ sign, and then I'm going to choose a distance, a start distance. Even though I'm entering it in meters, I'm going to display it in kilometers. So I'll just do the same for the end date. So ends or finishes on F8, the date, but now from the end group. So you've got these tokens, as they're called, and they allow changes to the data without having to change the annotations themselves. So, and it's a very useful technique, and you can add them to the task template, so it's there every time you want to do it. So I don't want it at the start, I want it at the end. So it's over there, and I want the bottom right hand corner of the box to be connected, and I can pick it up and move it, and I can spin it around through 360 degrees. I can give it a different font and a different background color. So I want it to be white. I want it to be a bit bigger and bolder. So that is now connected to the activity, and as it moves around, you'll see the information change. So you know, that has to, there's quite a bit of preparation, and all of that can live in the task template library and be used. So I've given this task a duration, and now I'm going to have a second activity. So I'm going to create another new activity. I'm going to choose a different item from the library here. So I'm going to say that we've got a fencing diversion, and that's going to take us 40 days perhaps. And if I don't like the color of that because we've chosen it badly, I can change it here, and I can enforce that. I can change the line style of that as well. We don't have to have solid lines. We can have any sort of line, and you can make your own lines even. And we can say, well, that's how did I arrive at 40 days? So we can calculate the duration of an activity. So we can say, well, not only can I give it a distance, I can give it some calculation. So I want to calculate the duration of this activity from the fact that I've looked in the bill of quantities, and there's 16,000 cubic meters of work to be carried out, or linear meters, and we can do so it's linear meters in this case, and we can do 400 a day. So but if we could only do 325 a day, then it would take us longer. So you can have this direct impact by plotting the productivity directly in Tylos, and then we can link these two together. We can say when this is started, this other one can start here, and it can start 10 days afterwards. So if we then reschedule that, we can see the knock-on impact. So if we were to start this a week later, we can immediately see the knock-on impact. So Tylos includes the full critical path calculation. We can import information. We're going to talk about that with more traditional systems, but what it's got uniquely is the ability to use distance as part of its calculation. So I've got some other things happening at a certain place, like a culvert or a bridge, and it's going to take us 25 days to do that. So the ideal place for that to happen would be just about then. If we did it too early, it would be happening before we've moved the fencing, and that would just be disruptive. If we leave it too much later, then we're gonna could have done it earlier. So we want to find a way where those two things meet, and so we can create a logic link, and we could give it the traditional sorry, I'm just changing this to a finish to start link. A start to start link. We want this as a start to start link, and it looks to be about 1, 2, 3, 4 weeks. So say 20 days. And so if I reschedule that, then you can say I was a bit short, so maybe 15 days. But it is a bit of a trial and error. There's no, well, that's good. But then if we were to change the productivity on this, or the whole thing moved down, suddenly it would be in the wrong place. So we can take this link, and rather than using time as a constraint, we can use distance as a constraint. So we can say that no part of that yellow box can bump into any part of that blue line, regardless of the position or duration of that blue line. So that's a completely unique ability. So where tunnels meet shafts, where stations meet track, those sorts of calculations are extremely important. So as you can see, Talos includes that data. It's great for sort of tendering and thinking through a problem. But what I want to do, I'm going to close this particular one, and I'm going to open one that I created earlier, so we can talk about some other features, and we can move on into some more interesting areas. So those fundamentals are in place. This is a sort of typical schedule, and we can also have different distance sections defined, and we do that in Talos by, in the project data under the distance section, we've got things called a sector profile, and that's where we can define as a little spreadsheet something with a name and a start and end distance, and it could have a reference to something where it can get its color from. So people often put those in, for example, a ruler, so we can, we split this job into 3 sections, we can indicate where they are. This is perhaps a road job as well, and we've got a couple of bridges, so we can indicate where those bridges are in the header, and we can also include that information on the body of the diagram. So if I click on the main part of the diagram and we go to the grid section, we've got a grid line setting here, but if we reveal this same line set, we can put a drop line down the whole page and give it a label if we want to, so that label will stay with it as it moves. We can see where the bridges are, and we can even use that as guidelines to create activities precisely between those locations. So so these sector profiles, as they're called, which is like a spreadsheet where you've got 2 distance values, are very, very useful, and you see that used time and time again to demonstrate interesting features on possibly both sides of the road or track, where you can pick out sections of, say, wooded areas or flooded areas or cut and fill areas, those sorts of that information. But there are also things called distance profiles, and so they are where we've got a single distance value, and then a number associated with it. So so that's used in 2 cases here. So one is that I've got 2 lines, so every 100 meters along this road, we've got the ground level height, and then we've got the proposed road height, and we can take those 2 values away from each other. So we can graph that in Talos. So that is not a picture, that's coming from the values in this table. So we've got, so when we get to 1 kilometer, the land is already at 38.9, and the new road will be at 40.5. So we've got so the green areas are a cut, and the blue areas are a fill. So you can have that sort of vibrant information to cultivate people's understanding of the job, but also uniquely we can use that to affect the duration of activities. So rather than it just taking us 45 days to do this, we can look at this particular activity, and if we go to the calculation tab, we can say, well, you've seen that we can set the duration when it's a uniform rate of production, but we can take that data from a distance profile. So at certain points along the way, we're going to change our productivity as set in this profile, and we're going to take the values from that profile and say that, well, if we can only do 450 is our benchmark 100%, that's the impact on the schedule of having that information lying behind it. So you don't have to have a single, you can have a single activity with a shape to it. You don't have to have multiple activities. Of course, with the distance links, it's got a brilliant unique effect on working out what this project is going to be like. So completely unique aspects in that regard. So we've also got, as I alluded to at the beginning, resource information. So in the library, we can make resources. They can be hierarchically organized. We can have machinery, labor, and materials. All can be defined separately. I've got a view already set up, which we can look at. So having defined those resources, and you can right mouse click and add a new sub resource here. Resources have got a lot of information on them. So if I double click on that, you see that we got shed loads of information that's useful. So we could take an activity and if we look at that activity, this is the resources that we've inherited from the task template. In this case, I might need 4 of these people, not 3. So I can change that value, and we can see that value change in a histogram. If I undo that change, you would see that change on the screen. So that's how resources can be viewed. You can have one per individual resource with a quantity, and you define a color set for that. And also I've got one here of all resources and the weekly man hours from everything happening in that week. So we've got that as red bars, and the blue line is the cumulative value shown in this table. So everything you see on screen is what you get when you print it out, and that could be financial values as well. So what we often interact with other systems in the world. So I'm going to show you how we would take some information out of Tilos. I'm going to put it in Excel, change it in Excel, bring it back into Tilos. But we could do the same thing to say Microsoft Project, P6, or Power Project. So if we want to export, first of all, and so this is where I would choose my destination. Some of these are extra modules that you've got to pay for. Everybody gets this one, which is the Windows clipboard. So we say, I want to send it to a CSV file or the Windows clipboard. And then what do I want to send there? And what column should it live in? So there is this idea of a profile, which you can define and have different ones. So defining the date format, for example, but also what do we want to send from all the data that's possible to send, and which column should it live in when it gets there. So these are the sort of the rules of which information we want and where it will be in which column. So if we click on OK, it's exported that, put it on the clipboard, and it's given us a quick heads up about that. So if we look at a spreadsheet now and we paste that, this information has come out of Tilos. So we could sort that, for example, in here. It doesn't make any difference. So I want to sort it by task ID. And so I'm going to make a change to one thing. So I'm going to say, well, culvert, this culvert here, these values have changed, and I've just copied them from another spreadsheet. So these things have changed from what they were before, and I'm going to add some new data down here. I need to give it a different ID number so it doesn't clash with one that has already existed, but we've got another culvert that didn't exist before, and I'm going to again copy it from another spreadsheet just to save time. So this is happening at different dates, it's happening at a different location, but it's got the common culvert reference, so it's going to be a yellow box when it gets created. So all of the highlighted items are new. So we just take that information back to the clipboard by copying it. We go back to Tilos, and we import it. And it's very typical that people import from a native P6 XML file. There's a detailed movie on our website about exactly what you do to achieve that. And basically, you've got to have the information that you don't have in project or a traditional system. You need a column for a start distance, a column for an end distance, and a reference to the name of the task template or the ID of it. And that is typically done in some systems with an activity code library, or it could be a user-defined field. But we're doing it from the clipboard, and we can see it's there because it's grey. We're going to use the same profile, the same rules that we exported it to bring it back in, and there we can see it's updated all of these things and created one new one. So there's the change to the existing one that happened, and this is the new one that has just appeared. So people use Excel a lot as a productivity aid for very quickly editing whole groups of things, but often Talos is used to visualize large projects, and it's being fed by information, partial information coming from other systems of only those items that are happening in distance. So so we've seen how flexible it is, and I just want to turn to two other things before we close the webinar, and one of those is about progressing. So Talos again has got a unique aspect when it comes to progressing. So I'm just going to get rid of the grid lines again of the bridges, just to simplify the diagram, so I wanted the one with progress on it, which is this one here. So so this is just another view, and I'm displaying the progress line, the report date, which is this blue line with the blue arrowheads. And the first thing I'm going to do is create a baseline. So a baseline is a snapshot at this moment in time. So this is my original plan. So it takes a snapshot of everything it needs to do earned value analysis. And you can have multiple baselines in a single file. And then we need to define when is time now, when are we recording progress. So it's at the end of the month. And that's going to set this blue line on the screen. So if I return to the screen, that blue line has moved down. Everything behind that line should now have been done. So now we can go out into the field. We can ask our colleagues and record for ourselves what's happened. So, so first of all, I'm going to take the topsoil strip. I'm going to look at the topsoil strip and look at the progress tab, because a key idea in Talos is that different sorts of activities can be progressed in different ways. I can progress by distance. I can say how much have we done, where are we now in distance. I can do the same thing with quantity. So I've done 1120 linear meters of 1500. I can do it in task steps of predefined bits that make up 100%, or I can do it as in percentage terms. So in this case, it's a distance task, so I'm going to use distance as that process. I'm going to right mouse click and get the dialogue behind it so you can see what's going on. And so we've worked the whole time from the beginning of the project to now, and where that line would cross the report date at this point, we should have got to 12K. So it's telling us the actual progress, the planned progress would be, you'd be on program if you got to this point. So the fact that we've only gone to 11K means we're going to be a bit behind, because we've done it in more time than we were allowed for. So I've set my highlighting of completed activities to be a sort of marker pen background. So the bits that have got a big yellow highlighting, and there are many other ways of doing it, that's completed. This bit is yet to be done. So you'll see that bit's going to get moved after time now. So we're doing the same thing with the spore removal. We're going to progress that. and the thing about that was that it didn't start until a week late, and they missed out the first kilometre. So there was some access problem. They couldn't get into that area, and so they've gone to 5,250 is where they've achieved. So that's what they've got. That's where they've got to. There's a little bit up here that hasn't been done yet, and that'll get moved by the reschedule. And there's a bit here that remains to be done. Now, this culvert is not a distance item. It's a fixed object, so I'm going to progress it by percentage, and I'm just going to say that we've done 10% of that, and we started it earlier than we anticipated. We started at the beginning of that week, and so you can see those impacts. So if we now schedule that, and we've got a little bit of the work here, and we've got this work pushed ahead, and we can compare it with our baseline. So Tiler's got a unique aspect by recording where you've actually got to, and there's no argument about those things as there are in other systems. So if it's a linear project, you can't do better. You cannot do better than Tilos. It's got another unique aspect, and that is something called Mass Haul. So I'm going to give you an example of that. I've got a much more complex one to show you later on. So Mass Haul is where we're building a road or a railway, or and it's usually across. So this is quite an unusual situation in the UK, HS2 being a classic right now, where we're going through the terrain and we've got to chop hills down and fill in valleys. So we've got a nice even road bed. And so we can find out where there are hills, and we can indicate what are called mass areas and the quantity of materials available at that space. And we can create those manually in Tilos, or we can import them. So underlying that are some mass, what's called mass types. So that is fundamental types, rock, spoil, things that have been cut, filled. So there's a sort of mass type creation, and then in the project data, there's mass areas, and then we can say, well, we're going to take this section and we're going to move it, and we're going to put it in this big hole here and fill up that hole. So how much of that fills up that hole is demonstrated by these sort of purple temperature gauges. So all of that 13,100 has been moved and is all gone because it's filled up, but it hasn't filled up the hole. So we're going to take this one as well, and we're going to move it to there, and it won't overflow it, but it just happens to fit exactly. So I've got these, which are these called, these are the haul lines. So we create the mass haul areas based on a certain type of material. We can set definitions about how fast we can do this, how much quantity we can move. Is the material, does it shrink or bulk up as we excavate it, move it and compact it? And then we can right mouse click on one of these lines, because that is the activity, and we can say that we want to create a pair of activities. We're going to cut it, we're going to move it in distance, and we're going to fill it. And the duration of these events is driven by that calculations that you've seen before, which are defined in the library. So so if I undo that creation, we can do it with all of those lines. I select one line, I do Control A, I've selected all of the lines, and so now we can create a whole cut and fill diagram in this manner, and then you've got other activities happening afterwards. So Tilos is uniquely good at demonstrating and using as a basis for planning the mass haul aspects. And so if we look at the impact, those resources are on the activities, and we can see the impact in these graphs of what our crusher stockpile looks like, and how much spoil we've actually moved to date. So it's rather good at doing those sort of things. So there's one other item I want to talk about, and that is it's heavily used in rail projects, particularly in light rail projects. So and I want to show some really good productivity aids in Tylos. So we're going to do a small amount of work overnight or over a weekend, and rather than taking individual tasks and building individual stages and linking them together, we typically do things in standard ways, and these standard ways are pre-planned as a fragment of a project, a fragnet, where we've got all of the tasks and we've linked them together in advance. So then we're going to say, well, we're going to take the content of that. We're going to not just plan to do a single task, we're going to do a task group. And then we're going to draw a rectangle. So it's going to be starting at that time, and it's going to fit into this area. And it's this particular sort of standard way of doing it. And we're going to start work at this time and in that footprint. So it's going to scale by distance the elements of already been predefined, and it's using certain parameters and certain resources. So if we look at this representation, this is a train which has got certain wagons, and they're full of ballast, or they're going to take the ballast that's been excavated, and it's calculated that there are 20 wagons, and the length of that train is shown on the diagram. So the train is sitting on that bit of track whilst it's happening, and then at the end of the process it's sitting on this bit of track because it's filled up its last wagon here. So we can take that, and these are defined in the library, so we can look at the allocated resources of that. And so our wagon is a wagon called a Falcon. It can hold 54 tons of material, and for that amount on this whole task, we're going to need 20 wagons, and that is calculated from the fact that this is the amount of material, and it's been driven from it's a special calculation tool that the industry uses if it's got curves, or and they say how many tons per distance, in this case a length. So if we say, well, there's only 26 there's only 26 in our ballast calculator result, so that is then going to reduce the total quantity of material to be excavated, and it means we need less wagons, and so the length of the train is shorter, and that's got a massive impact on when the following operations can start, and we can calculate the whole thing. So having preset standard ways of doing things and a good library can be a really powerful result. We can generate, of all the resources on this diagram, we can instantly generate a histogram for everything. So so there are all the steps, all the resources we need, and we can also show it as a Gantt chart as well as a time distance diagram. So if I double click on that, this is a standard Gantt chart. You don't necessarily need any other companion software to export it to and draw a Gantt chart. You do have all that information directly in Tylos. So as one of the tiny little aspect, we can draw a map at the top here. So if we the very beginning we imported a map, we can have graphics within the system. So I can draw a box, and in that box I'm going to insert a symbol from the library. I made this symbol with the graphics of Tylos as part of its library, and there's one called Worksite. So by doing that, we've defined where it starts, and this is in miles and yards, and what its length is, in miles and yards or meters. So it's 561 meters long. If I said, well, it's 600 yards long, that's how big it would be. So it's a bit tedious to do that manually. So people have built up libraries of the typical things you find on the route. So what we find en route are these symbols, the names of symbols in the library. The yellow things are what I've edited. So then we take that information, copy it to the clipboard, right mouse click in this area and import them. So it references items in the library and automatically creates them. So it can really, you can put a whole plan together within minutes, that would take quite a lot of effort any other way. So TILOS really has got some very unique aspects. So I've run through the A to Z of it, and I just wanted to throw up some other big diagrams to talk about it at the end. So this is a large and complicated mass haul diagram. So those sort of things happen as well. So this is a road job that, again, somebody said, and I think this is interesting here at the top, there are many of these ruling lines, and they all indicate where there are certain assets along the route and what the location of them are. So this is a sort of header information strip, and it's only down below that you actually have the activities on the body of the diagram. And it's again a very powerful mechanism of showing that sort of information. There's a very long pipeline here, several hundred kilometers, and the interesting thing about there is that we can have less productive periods. So there are often seasons of earthwork. People don't work between October and March or whenever it is, and we can represent that and have that as an impact on the actual activities on the program. Lots of resource graphs here, and that is the profile of the mountain ranges that it was going through. And finally, the most complicated one ever, which is Crossrail, large underground railway in London, and TILOS was used extensively in the tunnelling and the fit out. So it is larger than your average plan though. So I thank you for your time, and I hope you've got out of it what you wanted.